Alrighty. Let's see if we hit live. Alright, we hit live. I had somebody who wanted to see this. Let's see if I can... Alright guys, I've been feeling a little bit down. A little bit worn out. I don't know if I got the flu, bronchitis, or what the deal is. But anyway, so let's see where we left off. Well, first let me make sure that everything is visible the way that I intended for it to be. Okay. Make this a little bit larger for you guys viewing purposes. I can't. We're gonna have to compromise in the middle. I wish I could make it this big for you, but I won't be able to see anything. And I actually program like this, so I think that's somewhere in the middle. Full screen this, so that will help. Okay. Alrighty, sorry about that. Oh, we can actually just make it bigger like that. Cool. And it's still tiny, but all we're really doing is running Python and main. So, and this is where we left off. We're able to go to the edge, have our bounds on the edge, and I believe we have some bugs when we zoom out. It's not. When we zoom out, it should reposition itself that distance away from the edge if we are at the edge. But that's not necessary for us to have. If this was a game where we were playing and camera was the main feature of the game, then that would be fine. But it's not. We're doing a pathfinding and path generation, so for the sake of the code, we're just gonna keep going. This is sufficient. This is where we left off. We have a grid, we have the ability to zoom, and we have the ability to move the camera around. And even that's more than we probably need. You could probably just make a window that's the exact size of what you want, but I like this. So the next thing we should probably do is generate noise. And like I said, my brain is a little foggy right now because I've been sick. I'm gonna try to pull up, try to go through this. Let's just go from the top down again. We have our main entry point. We initialize number of screen squares. We might not even do this. Only render the squares in the screen. This needs to be part of our update function, or really our draw function. And this could be calculated implicitly, so maybe move this inside. But it's not going to really change it's not really going to change the logic of what we're doing internally. The data still needs to be there. Computation still needs to take place on every square. So for our map, I know that's the next thing we're going to do. We initialize our game, we go through, we set the game running state to true, we initialize the UI class. The UI doesn't really do anything but initialize the camera. We have the ability to update the viewport and render. So this is where we would say potentially the logic here. Self dot screen squares equals math dot ceiling, where we would have screen size 0 and square size. And we're not even using this for right now, so I'm just going to comment that out and leave a question here. But we update the viewport, we render, and these are implicit to camera. So we have our move function that we did, we have our zoom in, our zoom out, and the update viewport and render. So this just updates the current mouse position after we determine if we have moved the camera. And then again, zoom in and zoom out are handled here because of the PyGame event. Just seems to run better that way. I would like to potentially, maybe at the end I'll look at doing this, like optimizations. Update the location based on the zoom level if we are at the edge of the map. Maybe. Maybe we'll zoom to a point. Or maybe we should say zoom to a location. And then also another to do update zoom and location simultaneously. That might be another added perk, but these are not necessary for our ability to render. And so we inherit our draw from the map, and our draw just iterates through all the squares, and the squares get drawn. And so this is where we left off. We create the map. So we initialize the map. This function just generates a grid of blank squares. So the next is to generate noise and convert a sequence of squares to mountains or water. So define create noise, and know that we're going to use there's different ways to do this. There's probably a lot of different ways to do this, and some people will probably criticize this and say, well, you should have done it like this, or I know there's probably 100 different ways to create noise. Create a list of possible spawn locations. I don't remember why I wanted to do this. Oh, spawn combinations. Okay, so we'll get into that in a minute. Top left, bottom right. top right, bottom left, bottom left, top right, bottom right, top left. And then we'll import noise. It's our first package that we're gonna have here. And can we do random like this also? Will it let us do both? I know I have noise installed. Yep. So VS Code just isn't in sync with the packages, but that's fine. So what we're gonna do, this is actually pretty simple. We're gonna set a base. We're just gonna pick a random integer between 0 and 4096. Let's do that. Then we are going to right now we're going to pick a scale of 1. But this is where we're going to start implementing the UI manager. But it's not going to be needed. So actually scale, so I'm just gonna set these manually for now. I've hooked these up to sliders, and I'm gonna show you how to do that for your sake. I already know what values I want here initially, but I'm gonna show you how I determined what values I want. So there's a couple of fields, and we don't need these fields, but it gives some variance, and these are the values that I found that I liked. You might like something else, and these are, keep in mind, this is for simplex noise. We could use plenty of different noise algorithms, but no pun intended, I found simplex to be very simple to implement, and that's what I went with. So this is actually almost right. The number of map squares y and number of map squares x. And what we're going to do is we're going to say that if it's almost right. That's almost right. I just want to be, you know what? We're gonna see what happens. And there's one thing that we missed in squares. We forgot to add a boolean as to whether this is a path. So by default, a path is false. So we're going to say that we're going to pass it the screen, the size of the screen, and we could leave these at the parent level and pass these in to the draw function, and it would be less data, but it would be more data execution, I believe. But I think that Python really optimizes all of this execution anyway, so I don't think this is really something we need to worry about. Screen size, the index, the location, the size, the color, outline. Let's just put it at the end. Let's just default the path to be false. And we're gonna have the gray grid. What we're gonna do here is actually, how do we want to do this? We're gonna assign this a new square. Y times the number of map squares x over here, self.in plus x. That's how we get our index. We multiply what row we're on times the values in a row, and then add the index of the current x location to get the absolute index. And then at the end, this is still going to be false, so we don't have to do anything. But we can say else self.squares. Oh, we're already calculating index here once. So let's just say index equals this value. And then we can pass an index here. Squares index path equals true. So if we are not on, I want to say brown, brown and 0. We do not want this to be an outline, we want this to be filled. So, and I feel like we need square size. We do have square size here. Square size, square. Dot square size equals. Doesn't really matter where we put it, but that way we're not hard coding these values. We are dynamically assigning these values from the top level. Okay, let's try a simple run and see. That did nothing because map create map never calls create noise. Alright, now let's try it. So we have some mountains. So this is actually using this is not the simplex noise. Perlin noise, and that's fine. Perlin noise is fine. I want to make sure. I would like to look up Perlin noise variables because I almost feel like, so I know this is what how we use simplex noise. I'm not actually used to Perlin noise in Python using the noise library, so I'm assuming this is right. So this would be a good time for us to go back and define our manager. So we pass in the PyGame GUI, library, the UI manager function, and pass in the screen size tuple to the UI manager. This gives us an instance of the manager. On the map level, I'm going to create a class, a noise class. We're going to just say, and I don't really like doing it like this, but this is just a way. Scale equals 0.1. Lacunarity. And then here we will say self dot noise factors equals a noise class. And then here self dot noise. Actually, let's just for the sake of typing self.noise.scale, .octaves, .persistence, and .linearity. And why not? Since we're at it, let's just wrap the base in there. Actually no, we'll leave base to be inside of this function. No need to abstract that out. So, because this is in the child class, or what some might say it's the parent class, because it's inherited here, we will be able to access those variables at the top level. And then we're gonna create forgot this is in C for a second. I'm gonna create an array of labels, values, and sliders. These aren't really going to do anything just other than just hold our instances. So create a init sliders. And what we'll do, we'll have to create, well, we'll just do this one first. We'll say self.labels.append this is close to what we want. But we're going to say PyGame GUI.elements.UI label, and then PyGame.rectangle, and of course we don't have PyGame here. And we're going to put this at 30, 20, with a size of 50 and 20. We're going to call this scale. We're going to pass it to manager, and we're going to give this an object ID of scale label. And then we're going to add a sliders. And you don't have to do them exactly in this order. But this is close. So the logic here is that this is the object that we are drawing. This is the initial value. This is wrong. This is why I say I do not like to depend on Copilot, because it's not always right. This is our minimum and maximum value. And then again, we pass the manager and the object ID. And then here we will add the values. This is almost right. We're gonna put this in here, but I know that I want it to change based on my notes. The X and Y of this, so the logic here, and this could be moved up. You could put this above this. The label and the value could go together on the same line. It doesn't matter. But the thing that I like about this is that this label is attached to this slider that controls this value. But you can put it either way. So, what was I gonna say? The logic here was that this label starts at 30, and then the value is on at 120, but they're on the same line. They're both on the Y of 20. I think this is about right. I don't know if well, we are going to need an update function, but we will eventually need to initialize buttons. But that will be, we're going to have one button to create a spawn button, because I want to create more spawn locations. But this is our scale slider, and we will need a octave slider, a persistence slider, and a lacunarity slider. Let's see how much this gets right. So 30, 60, 65, 20, 30, 80, 220, 1 to 10. So this is actually learning from my previous iteration, because this is all of the code from my previous version. We don't technically need these. Doesn't hurt to have them. We don't technically need these either, but you can look up objects by their object ID, so it doesn't hurt to have that. $90 and $20 is previous. $1.5. And so here we can actually use these values. So we can say self.noise. We can actually say self.noise.scale, self.noise.octaves, self.noise.persistence, and you can see here where we're grabbing the string value from this slider. So we append this slider in here, and then that's why we're putting this third, is because we're immediately after we're grabbing the current value from this slider. So we're essentially just passing this value back to here, but it just seems smarter to link this specifically to that property of this. And then linearity. And let's check these values. 30, 140. My previous version I did 85. 30, 160, 220. And the same range, 120, 40, 60, and 20. And you can experiment with these and create your own configurations. But this is essentially how we would implement that in this, and you will see that up here we should have these boxes when we call the init sliders. So when we create our UI, this is where we will just say init sliders. And this won't do anything by itself, because we need to PyGame display. Let me turn my heater off. It's getting warm out here now. Winter is almost over, so we will be retiring the heater soon. Oh, it's not even winter, it's just... it's almost that time of year. So let me look. That's right. So when we call update, we will actually call self.manager update, and then we will call the clock. And right now, the clock is only on the main level. And we will also have to call the screen. So we're gonna have to pass the clock in. Unless we pass the clock into the game update. Could call both of these in game update. Let's look at that. If we call game calls update here. Could call it here and say PyGame display and clock. But we'd have to pass in game as part of the surface game. I mean, clock after the screen. Clock after the screen. Then we would call the clock here. And then when we initialize the clock, we would say clock equals, and oh, we don't even have to pass it in. What am I doing? When we initialize the game, we initialize I, we would say that clock equals PyGame dot time dot clock. Do we need this screen at the top level? We do need the surface to fill it. But we could also do the same thing internally. Get rid of surface here. Get rid of the screen here. Get the screen here. Get rid of the screen here. It doesn't feel right to pass it, to go any further than this. I almost feel like we should stop nesting. Even though, because I know that screen goes all the way down to the bottom. To the map, and putting screen inside the map just does not seem right. But putting the surface, the clock, and the manager inside the UI doesn't seem like the worst idea ever. I'd almost rather have them more at the parent level, but that doesn't seem exactly right either. So at this point now, in our game.update function, we will fill the screen to be black. We will update the manager, and the manager will get the self.clock.getTime, and actually this seems like it should go down here. Self.manager.drawUI, and we will pass in the surface. And I believe that's it. Other than we need to import color. So now, while we're running the game, we check for events and we update the game, and that is it. We initialize PyGame, we display the caption, set the caption. Yeah. So this looks a lot cleaner now. There's not a whole lot of anything in our main function now, which is kind of nice. We have the game superclass that we call. And really, you could probably factor this out even if you wanted to, or move things up. It's easier to move things up than to move things down. But let's see if we can run this. PyGame's UI element has no attribute UI slider. That is because I let the autocomplete write for me. It is UI horizontal slider. And here are our sliders that don't do anything because I forgot to do something. So I know we need to update the sliders. So there's two aspects to update sliders. We are going to have to well, that's actually what we're gonna have to do. But can we not say for slider and self.sliders? What do you got there? That's not what we want. What did you have before? So this is going to update the values. And that's right, that's the right way to do that. I would have done this manually. But the real thing that we actually want to do, so instead of doing it like this, which would make sense, we actually want to say self.noise.scale equals the first value, because this is our first item in the sliders value, and then self.values.0.set_text, and we convert that to a string. And we're going to do this for each value, and I could have let Copilot write for me, but I want to be explicit here. We're going to update the octaves, we're going to update persistence, and we're going to update the lacunarity. So when we move a slider, it's going to update the class object that we have on the map level. And then that will update the values here in our noise function, which will update the results of this. So then we are able to call create noise again. And then that will update the map. The only thing that we are missing is at the top level. While the game is running, we need to game.manager.process for the events that happen. We need to process the events. This is why our sliders was not moving. So this will register that the sliders have moved. If the event type is quit, or the event type is a button, or the event type is a user event, and the user type is PyGame GUI UI horizontal slider moved, and we need PyGame GUI here. You could probably do this in the update function, but it just makes more sense to process the user event in the event processing loops like we are doing with our mouse event. So our input handling here. And like I said, you could probably nest this in a function that says, we could probably say update inputs and do something like that. Let's say self and maybe this is nicer. Process inputs. And now while the game is running, we game.process inputs and we game.update. But if the type that is moved is or the type of event is a horizontal slider, if the UI element is in the game self.sliders, because we have an array of them now. Excuse me. We will self update sliders and self dot create noise. And then one last thing that I remembered is that we cannot just set the path to true here. Whenever if we do this, we can run this. And we should be able to move these now, which that's kind of cool. But the problem is that we're not getting rid of any values. We're only adding more values. And this is probably not absolute. Maybe we need to allow higher octaves. Let's allow up to 5 octaves. Now let's say 10 octaves. Or that's scale. We'll allow scale up to 10. But the thing here that we have to do is we have to reinitialize all the other squares. So we're just basically appending all of these new squares, and we're never reinitializing the old squares back to being hollow gray squares. And then we will set the path variable to be true. So that we know where our paths are at all times. And so when we run this now, if we move the scale around, we can see different. The persistence doesn't seem to do anything with, occasionally like it will do something, but I don't understand what. Yeah, these don't do anything with Perlin noise, and I'm probably not doing anything doing this right with Perlin noise. This is why I was actually using simplex noise, and let me show you that. So simplex noise gave me a bit better results for map. So the whole time you're holding it down, it's updating, which is odd. The buttons don't seem to work very well sometimes. But what I have found is that chaining these together proves to be quite interesting. And the logic could be improved here. And let's even factor in scale to be 0.01. So we can have a really tiny scale. And so yeah, now we can have like some really, really ridiculous scales. And I think maybe that's a good factor. 0.08, I like that. We'll get, see, and this is what I was using these for. So 0.08. So let's initialize scale as 0.08. And that might be something to think about with Perlin noise, is that maybe the lower scale, and because these multiply, so it increases a factor in an inverse way. But maybe the other thing too is that I was using too high of a value for this discriminator. So this is kind of Perlin noise we're getting now. But something that I liked doing was saying like 0.05. I'm going to copy this. And I'm going to say these are blue. And what we say? 0.0, we'll say 0.35 for Perlin noise. And we're going to do simplex noise for the mountains. Do I have a blue? Why is my color blue not showing up? I do not have a blue. Go with that. I like that factor. But what I'm going to say is we're going to add another factor here. We're going to say scale times 3 and times 2 and divided by 2. Actually, I don't know if that will work. If octaves is 1, can't divide it by 2 if it needs a whole number. say 0.6, and then we're going to do another line. So I want to like increase the make it less uniform. Point times 4 times 6, and so these will be smaller like fractals essentially. But the other thing that we're going to do here is we're going to say base plus 1, and then base times 2. So these are different factors. So this is what the number that's being used to create the noise. So this should create a little bit more unique maps, and then we should also have brown and blue to represent. Oh, this only showed water now. So these would be bodies of water. What did I do wrong with the simplex noise? Am I overlapping my noise? Yes. So now we have mountains inside our bodies of, or we have combination of mountains and waters. And this is probably not the best thing in the world, but it works. Our water's factors are not really changing a whole lot. Maybe we could try something a little bit different. What if we do say that our octaves is 2, and we start with a slightly different scale? I kind of like that, kind of. But that makes me want to. So the other thing to think of too is that this actually changes the orientation. So if the scale in the y direction is twice as likely, then you will get horizontal lines. The other thing to think about is there's different aspects of how likely that this value will return a number that's larger than that, because you're actually getting a gradient here. We're trying to turn it into binary yes or no, but you could actually map the entire gradient. We could actually use these to determine color values if we wanted to. But because we're trying to build a pathfinding algorithm, we're trying to determine a black and white binary path. So, I think for the size of the map this works. I kind of want to make... Well, this will be fine for now. What happens if we drop these numbers like way low? And also we divide this number by 2. Yeah, so now we have more complex maps. The problem with this is that we're not guaranteed to get through to the other side. But what if we make the water larger also? And I could be using I know I could be using sliders to adjust these values also, but that's fine. So this is probably pretty good. There's enough clearance to find a way through. So this should work. So Um, Out of curiosity, if we switch these both to purlin, what happens? We get a lot less, a lot more natural looking, but a lot less complex map. I'm gonna look real quick to see. So I initially on my other project had this value set to 1.75. And I think we'll do that because that makes very difficult to navigate paths, but it ultimately will allow a path. But maybe we'll scale this up just a hair. And same for these 4.25 and 5.15. How about that? So that's bigger areas, less static. Let's increase the factor of the water because I like the water. Cool. Now the only problem is we're not guaranteed to get through. So toned back just a hair. Yeah, that looks pretty good. Let's just generate a couple more of these just to make sure we are indeed getting paths. It's pretty useless if we don't have a way through the map. So yeah, that's a way we can generate maps. And you could ultimately turn these into 3D and generate height maps or layer these things together to create terrains. But yeah, that's pretty much that aspect of this. So either we stop here or we go ahead and we implement the next step. But before we do that, let's go ahead and comment out the UI aspects. We can come back to that. And just make sure that we are still getting the map as we intended. Okay, so the next thing that we're going to do is we're going to generate spawn and endpoints. And we'll come back to this to do. But we will create locations, and this one's kind of fun. But this is where Pathfinder, we have start and end locations now. And if I remember correctly, I think that we just store an actual index here. Actually, this is so this is a bit redundant. We'll just leave it at this. This is going to be a specific, what we call this index, actually. An ending index. Because we are using our squares in an array of squares. Our map is essentially an array. Our squares are an array. So here we have an array of squares, so we can determine explicitly if this is a start or end. But there's a function that we're going to use. So we want to find a path. And so we are going to say start and end, because we want to find a path within a specific area. So this is where import random, and we will say that the index is a random number in a random location. It's between the start and end. And then, while we are not in a path, we will continually update this index until we get an index that returns a true value. And then once we have a path, then we can determine that this is a valid index. So, we need to create a list of possible spawn locations. So, how are we going to do that? Well, this is the fun, tricky part. Because we have to do some modulus math. So, top left would equal 0 to screen width divided by 3. And this is our X location. And our Y location would be 0 to screen height divided by 3. The top right would be the screen width minus the screen width divided by 3. And so this actually, I need to rewrite this because this is not the math. So this is our height. This is our width. So our screen width, so our height is still 0 to the screen width divided by 3. No, that's X. That's X. I got this backwards. I've got myself confused. Oh, right. So the screen width less a third of the screen width all the way to the screen width is the X location, while the Y is still 0 up into the top third. The bottom left would be the 0 to the screen width, third of the screen width for X. The screen height minus a third of it all the way to the screen height. So I think that's right. And then the bottom right would be a combination of those two. Yes, yes, yes. This looks right. But where this gets tricky is that we're using an index value. So I already know we're going to need to come up with index to position, where we take an index and we return a tuple. So the index modulus the x, and then the index divided by the x. And to show you this, if we have my paint skills are horrid. We have a simple grid. I'm not going to do the whole thing. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So if we have number 9, this is 0, 1, 2, 0, 1. So we have 6 in a row. So 9 divided by 6, if we rounded this out, we only get 1. Or if we floor it, we're going to get 1. So then we can determine that our index divided by our width will give us our y value. And if we can modulo this value, 9 modulus 6 would give us 3, but if we do the width, which in this case is actually 7, then we would get a remainder of 2, and so that will give us the x. I'd encourage you to go through and do some of these yourself, especially if you don't really fully grasp what I'm saying. The other side of this is that, excuse me, we could get position to index. This one should write itself. Yeah. We're going to say y and x. And we discussed this before. The row plus times the width plus the x. I need some tunes. I don't know what happened to my music. I'll probably get flagged for copyright.
Head of marketing at a ketchup company about to use
But
Grammarly to handle
it's okay.
2 weeks. Not ideal. Good thing Grammarly's tone suggestions can help move things forward, because conveying confidence can make the impossible feel possible. Now you just have to tell your team.
2 weeks?
You got this, Dave. The right positive tone can quickly motivate them, because there's work to do and a new product to launch. Looking good, team. And here we go. With a big pitch, you need a little charm. A more personable and friendly approach can help win over clients. Dave, did the right tone just convince them to buy it all?
So, for us to determine these values, what is the best way to do this? I want to put this in an array. And really, I don't really care for Python enumerations because they're not real enums necessarily, because you can use an enum that contains actual values, and in which case that's not an actual enum in my sense, in my opinion. But they can be useful. So we could say a class quadrant is an enum. And then we could say left x right x bottom x top x, whoa, bottom x. And these would be bottom y, top y. So then we get combinations. So top left, top right. But this is not exactly what we want either. I wonder if can we add an init for maybe this is not what we want. I feel like this is close though. Like, I feel like this is kind of close to what we would want. And then we could say Um, I wonder how much that you guys can hear. I'm not sure if you guys can hear me sucking on my gum. I bet some people like it and some people can't stand it. We're gonna set these to none because that seems more correct. Since Python totally cares about data types. So, self dot end quadrant is going to be a random choice from the quadrant's location. And we will call self.createLocations and just see if this works. We're going to print the end quadrant. And let's just run this. So we got quadrant left and quadrant left. So we are in the top left. Oh, that's left X. Why is it 2? I'm confused. End quadrant is a tuple. Why did I get left X and left X? That has me super confused. In theory, these should be constant. Right X, left X, that's not right. Why is it just picking random? It should be a combination of these.
Oh, hey! I was just going for a drive, which is wild because up until very recently, the thought of driving more than 5 minutes away would send a surge of adrenaline through my veins and keep me trapped in my house. Stuck City, population, Daniel Thrasher. That sound familiar? Let's take this outside. Luckily, I signed up for...
You know what we could do is we could create a function that says define get random quadrant,
you can start communicating within 48 hours if you want.
and then this would just pick a random one.
Counseling done securely online. BetterHelp is available worldwide with over 20,000 licensed therapists to go. Because they know it's important.
Part 1.
Match, they make it both easy and free to change therapists at your request. It's more affordable.
What do you call it?
Aid. Join the over 1 million people.
First deviation equals this, and then if that's one way to do it. There we go. That's kind of what I was wanting. Let's see if this does what we want to do. Quadrants dot get random quadrant. Missing one positional argument self. Because it doesn't exist. So we want to say static method, get rid of the self. list takes it post one argument. Oh, let's just listen. This is why autocomplete is not the superior method. We're still getting left X and left X. I feel like there's a bug here or something. Of course. Where? How? We got a left X. So if it equals a left X, why is that happening? I don't understand this, the logic. This is probably something so dumb. Some of you are probably like screaming at your screen right now. Some of y'all probably skipping ahead right now trying to figure out where I didn't, to get to a part where I didn't mess up. I don't think this will make a difference. Yeah, I don't understand how I'm getting duplicates.
Let's put some gravy on it.
Trying to do some homework. I'm not even sure how this is possible. Like, why is it picking the same value? Like, if the first value is quadrants right X, then we should be hitting here. But I don't think we are. We are hitting there. So then why is it not? Is it a scope issue? I mean, like, how is it gonna pick right X from here? Like, how is that even a thing? Second deviation, that's not an option. How did it know I was gonna type farts? How did it know? So that's working. So we are hitting the loop. Then why? Oh, because we're using an enum and these values are the same. I guarantee you that's what it is. So we're gonna have to change our logic here. That's what it's gonna. We're gonna have to use a proper enumeration. I'm fine with that.
Acetaminophen blocks pain signals. Advil dual action.
Yeah, top left. That's crazy. Well, you learned something new. But we could have just done it the way we were doing it before. But since we already wrote the code, we'll just leave it like this. But since we're having to do it like this anyway, since we don't get to define our 4 segments, we'll say top left, bottom left, because why not? Top right, bottom right. And then now all we have to do is define get random static method. Why does it not like that? Is it because we're returning a single instant now? Can you get a random instance? Doing.
口寄せの術。口寄せの術。
Bro, my mic has been muted this whole time that I've been talking. Jesus Christ. Oh my god, I feel so dumb. I'm gonna have to go back and add like captions to this entire video. Oh my god, I feel so stupid. Okay, with that, I think I'm gonna call it. Yeah, I was talking about drawing the screen squares. We can draw the squares, but we have to factor in the zoom and where the camera is, and then figure out if the index is inside the range of number of squares that we have available. It's just some tricky math that's not much more complex than how we found a path, but we still have to figure in the start x, index, start y, and end y, and if a square is in those that range. But nevertheless, we have squares spawning. We have a start and end location, and I said those backwards. We have our map generating. The next thing we'll do is we'll create a button that allows us to create more spawns, because it's nice to be able to see it happen multiple times without having to reload the program every time, and that's something that I didn't do in previous version of this. But yeah, we have the Pathfinder, we have the map, and the we create our map, create our noise, and create our locations. We need to add in the quality check for the endpoint, because if an endpoint spawns in an area like this, then we can't navigate through the rest of the map, and therefore we need to collapse this area and find a new endpoint. So we have plenty to do the next time we do this video, and that's what we'll do in the next video. Is we will add the button for making multiple start spawns. We will add in some BFS and some sanity health check type things, which those are not the right words, but with my current mental state, like this for example, this would not be a valid spawn, so we would have to do a check, collapse that location, and find a new target endpoint. But yeah. Anyway, oh god, I can't believe I just spent like an hour or more talking with myself muted. For everybody who has watched this and has been following along, I definitely appreciate it. If you have any questions, comments, or anything that you would like to add, or I just realized that my scale is not even, which is why my lakes have not been evenly shaped. There we go. Yeah, Jesus, I can't believe I just did all that. I'm gonna put the water on top. There we go. Maybe we'll give them a 50% chance of being able to swim. Oh man, I feel so dumb. But anyway, thank you guys for watching. This is all I got. I'm gonna go and do something other than sit at my computer. I hope you guys have a good day. Feel free to hit me up.